Happy day, students. In our last class we studied about electrostatic force, which we can call as Coulombian force also. This force can be called as Coulombian force. And this law through which we got this is known as Coulomb's law, which says that the electrostatic force between two charges is directly proportional to the product of two charges and is inversely proportional to the square of the distance between them. Okay, and what we learned in our last class is this force not only depends on the product of two charges and the separation between them, it also depends on the medium. If the medium is different, force is also different. Okay, and this force, its unit is Newton, and any force that we are talking, we know is vectorial or a vector quantity. So this also has to obey the vector laws. But again, this force is only acting along the line joining two charges. Remember that it always acts along the line joining two charges. Okay, let's do some questions based on that. So first question, if I am writing, very simple question. If I say that there are two charges Q1 and Q2 and the separation between them is 1 meter. Okay, the question says what can be the minimum possible force between two charges Q1 and Q2. In this one, Q1 and Q2 are variables. That means we have to find Q1 and Q2 only because the separation is already given. And this is free space. Okay, so what can be the minimum force between the two charges? Minimum force between the two charges is possible only when this Q1 and Q2 are the smallest possible charges. Correct or not? So what are the smallest possible charges for Q1 and Q2? 1 electron's charge. That means this also can have the charge of 1 electron. This also has the charge of 1 electron. Then what will be the force between them? 1 by 4 pi epsilon naught. Q1, Q2. So Q1, Q2 by R square. So what we are getting? If I write this as one constant, let's say K, then this force is Ke square. Okay, this is the question which is asked in one of the competitive exam also. What is the minimum force between the two charges possible? Okay, it's a very simple question, but asked in competitive exam. Next question, let's see. If suppose three charges are there of the same magnitude. Okay, three charges of the same magnitude I am going to keep as the vertex of an equilateral line. Here is charge Q, here is charge Q, and here is charge Q. Okay, and let's assume that the separation between all is 1 meter. Okay, and I want to find how much is the net force on this charge alone. What is the net force on this charge? So first question is, when you are going to find net force, let's say this is A, this is B, and this is C. So net force on charge capital B. Okay, so is this charge Q is experiencing force due to this charge Q? Yes. Is this charge Q also experiencing the force because of this charge Q? Obviously. So because of this charge Q, where is the force on this? Attraction or repulsion? What is the charge on this one? Positive. This one positive. This one positive. So what kind of force is that? Repulsive force. So this charge on this charge is going to apply repulsive force. What will be the direction? On this force, on this charge, where is the force applied by this Q? In this direction, like this. Okay, because when you say because of this, that means you are making it fixed. But this cannot move. So because of this charge, where will this charge go? This direction. On the line joining two charges. Remember always. Same way, because of this charge, where is the force on this one? Again, fix it. Now, where is this going to apply force on this one? Line joining two charges. Which force? Repulsive force. Again, this direction. Okay. Now, if suppose I say that because of this Q on this Q, the force is F. Let's assume. So, because of this Q on this Q will be what force? Again F. Why? Because charges are same and the separation also same. So, this is also F, this is also F. These are vector quantities. So, how to find the net? By vector laws. So, first we have to find what is this angle. It's an equilateral triangle. So, this angle is 60. So, this angle is also 60 degrees. So, what will be the net force then? Net force will be F net on B root over F1 square plus F2 square plus 2F1 F2 cos theta. That is the law. Okay. So now F1 and F2 in this case are both equal. Yes, keep it equal. F square plus F square plus 2F into cos. What is the angle? 60 degrees. So cos 60 degree means what? Cos 60 degree means half. 1 by 2. So this 2 and this 2 gets cancelled. Okay. So what we are getting? F square plus F square plus F square. 3F square. So what is we are getting ultimately? F root 3. Now we will be writing F value. What is that? F value is 1 by 4 pi epsilon naught Q into Q, that's Q square by R square. What is the separation between them? 1. So 1 square. So what is the answer? Answer is root 3 by 4 pi epsilon naught Q square. Okay, in this particular question it's like this. But now if suppose I change this question. I'm going to change this question and instead of positive Q, I'm going to put negative Q here. At B, let's assume there is negative Q. And still I am saying find the F net on B. Then how to find? So this minus Q because of this Q. Again, make it fixed. So what kind of force is applied by this Q on this minus Q? This direction. Attraction. Okay. How is this force applied by this Q on this minus Q? Again, attraction. So it will be in this direction. Magnitude again is going to be same because here the charges and here the charges are same. And the separation between the two charges here and here is again same. So you can say this is again F and this is again F. Okay. And the angle between the two is again 60 degrees. So it means magnitude will be same on B. Yes, magnitude is same. We root 3F only. But the direction this time is like this. This will be the net force. Is that clear? Same question again. Okay. Same configuration, same equilateral triangle, 3 charges. Okay. But this time I am asking you if at the centroid I am going to keep a charge Q. What is the force on that? This is 1 meter, this is 1 meter, this is 1 meter. What is the force on Q charge kept at centroid of equilateral triangle? Okay, what is the force on this one? So, other than this Q charge, how many charges are there? Q, Q, Q. 3 charges are there. Are all 3 going to apply force on this one? Yes. What kind of force? All are positive charges. So, all will be applying, all the charges will be applying what force on this one? Repulsive force. So, again, because of this Q, on this Q, what is the direction of the force? First thing, let's join them. Because we know that the force is always along the line joining two charges. Because of this Q, on this Q, force is like this. Okay, if this is A, this is B, and this is C, then I can say that this is FB due to charge at B. What about C? Again make it fixed, and C in which direction this is going? It will go where? Away. So again, this direction. What about this? Join it Again this is positive, this is also positive, make it fixed. Where will this Q go? Down. So like this. Okay. What are the angles between 3? This angle is 120 degrees. This angle is 120 degrees. And this angle also is 120 degrees. Okay. Now we have to find the net force. Do you feel that it will be 0? It is going to be 0 only, because all the forces are equal. This FB, because this distance, now that also we'll discuss. What is this distance and what is this distance? Because normally in all the questions, they will be asking you that distance also. So you should know that. Okay. So if suppose that this 1 meter, I assume as L. Okay, do it for L first. Alright, and centroid is the point which divides the median. This is the median. It divides it into 2:1 ratio. This is 2, this is 1. Okay, so how much is this and how much is this we have to find out. So this distance from the base, one of the sides, middle of the triangle to centroid, that distance is L by 2 root 3. Okay, and this distance is L by root 3. This is double of this one. This distance is double of this one. Remember that always. So here in this case, L value is what? 1. So this will become 1 by root 3. And this one, 1 by 2 root 3. Is that clear? Okay. So now, what we can do? We have to find the force. Which force here we are finding? FB. Let's see what it is. So FB is again 1 by 4 pi epsilon naught Q by this distance. Now for the time being, take it as x. Okay, I am taking it as x. So q by x square. Now let's talk about FC. Now FC also, this distance is same, x, 1 by root 3. And same way this distance is also x, which is 1 by root 3. So that means all the forces, FA, FB and FC all are equal. So FA, FC equal to FB. Numerically all are equal. Now how to add this? There are 3 forces, right? So first of all, this I am removing here. Okay. All these are not required at the moment. Okay. So first I am adding this FC and FB. What is the angle between them? I told you the angle between them is 120 degrees. Right? And since this force and this force are equal, so the resultant will be in which direction? It will be bisecting the angle, like this. Okay, and what about this? Will this be exactly opposite to this one? Answer is yes, because this angle is also 120 degrees. This is also 120. So this will be the bisector of this and making 180 degree with this. You check. This is 120. If it is bisector, then it will be 60. So they will be at 180 degrees. That means they will be exactly opposite to each other. So fine. If suppose this comes out to be equal to this, then sum of this one and this one will become 0, because they are acting opposite to each other. Okay. So let's see. So FB I assumed as F, and FC also I am assuming as F, which is value is this one. Okay. So see now, FBC I am adding. It is equal to FB square plus FC square plus 2FB FC cos 120 degrees. So FB is equal to F, FC also F, 2 into F into F cos 120 degrees. That means minus 1 by 2. Minus 1 by 2. See? This 2 and this 2 get cancelled, and this is minus F square. Minus F square and plus F square is gone. Resultant is coming just F. So this is F. And what is this? This is FA. And what is FA's value? Same as that of FC and FB. And what we have taken FC and FB here? F and F. So that means this is also. This is F. This is F. Then resultant is 0. So since the charge is kept at the centroid, all the forces, all the charges in fact are applying type of force on that one, and the resultant is 0. Okay. Now let's see, if I am going to change the charge, then what happens? At the same centroid, now this is the triangle here, this is plus q, this is minus q, and this is q, and again at the centroid I kept charge q. This is 1 meter, this is 1 meter, this is 1 meter. Now what's going to happen? This q will apply force on this one. In which direction? Repulsive. Like this. This will apply the force. Again repulsive. This will apply the force. But is it repulsive? No. It's like this. So if I say this is F, and this is F, do you think it will become 0 here? No. It will not become 0. Okay. So you can add this. What will happen? What is the angle first of all between these two? This and this. That's 120. So again 120 degree we can add. Okay. But their magnitude, the resultant will be coming exactly in the middle only. That means angle bisector. An angle bisector, that means along F only. So we are going to add these two forces. Okay. You will be getting the force in this one. You are not going to get 0. Again I am saying here and here angle is 120 degrees. Forces are equal. So their resultant will be on the angle bisector. And this force, because of minus q, is also an angle bisector only. So both the forces will be added. So here I am writing it directly. The answer will come as 2F. Shall we check? We can check it. If I say this is F and this is F and angle is 120 degrees, then we already found in the previous question the resultant of them was F only. And already one F is also acting because of minus q. So total force will become 2F. So if we write this value, 2 into 1 by 4 pi epsilon naught q into q by this distance is how much? 1 by root 3 whole square. So this is our answer. That is 2 here. This root 3 will go up, become 6. 6 q by 4 pi epsilon naught will come as the answer in this particular question. Okay, so we checked all the possibilities as far as triangle is concerned. Now let us go on another geometries. We can go on to the rectangle or square. Let's see, we are going on the square. Let's see what happens. If there is a square. Okay, here is q, here is q, here is q, here is q. And again you take this as okay, this is L. And I want to know that what is the net force on charge at A. Here how much is the net force? So who are the charges we are going to apply the force? This charge, and this charge. All will apply the force. Which direction this will apply the force? On Q. What we will do? Fix it and see whether repulsive or attraction. Repulsive. So away. Again because of D, fix it and then see where is the force applied on A charge. Repulsive. So like this. Same way this one. See, this is the line joining. So this Q is applying what kind of force on this one? Again repulsive. So like this. Will all these three be equal over here? Answer is no. Why? Because here separation is L, here separation is L, but here separation is what? Root 2L. So all forces are not same in this case. This force I can say F. This force I can say F. But this force I cannot say F. It is I am writing as F1. Okay. So what we will do? How to calculate? First we will add F and F. What is the angle between them? 90 degrees. Are they equal forces? Yes. So what will be the resultant of them? On bisector. And F1 is also acting on bisector only. So net force on the charge at A is going to be F1 plus root over resultant of this, which is that F square plus F square plus 2 F into cos 90 degrees. Cos 90 means 0. So this factor entirely is 0. So what we are getting? F1 plus root 2F. Now we can put the values. What is F1? What is the separation in this case? Root 2L. So 1 by 4 pi epsilon naught Q into Q, that is Q square, by root 2L whole square plus root 2 into F. What is F? Force between this and this. So again 1 by 4 pi epsilon naught Q square by L square. So I am taking 1 by 4 pi epsilon naught common. What will you write? Root Q square by L square. This will be the net force on charge at A or charge at B or charge at C or charge at D. On all the four, if we are going to find the force, it will be this magnitude. Okay. But if suppose I am going to make one charge negative, if one charge is negative, then what is going to happen? Let's see. This is Q, this is Q, this is Q, and this is minus Q. Okay. A, B, C, and D. Now I want to find what is the net force on charge at C. What's happening here? See then, on the charge at C, if we take this as L, because of this charge, on the charge at C, what kind of force is there between them? Repulsive. On C, which direction will be the force? Like this. Okay. This charge B is going to apply force on Q. It's attraction force or repulsion force? Attraction force. So where will be the direction? It will attract it. So direction is this. And then this force, QA. This is the line joining the two charges. Okay. What kind of force is there? Repulsive. This we are making fix only because the force we are asking on this charge. So where will be this going? Like that. If I say this is F, because this is between these two Q's and the separation is L, then I have to say this is also F, because here also charges are same and separation is L only. But here is something else. Now how to find it? Now first we will find the resultant of these two. F and F we will add, and where will be the resultant? Angle bisector. And what will be this force? We know it. Okay, so this is angle bisector, that means this is 45. And what is this angle? This is also 45, so that means this is also 45. So what is angle between F1 and root 2F? That is also 90. So what will be the net force? F1 square plus root 2F square plus 2 F1 root 2F cos 90 degrees. Okay. Cos 90 is 0. That means this factor again gone. What we are getting? F1. Now what is F1? I am writing its value. 1 by 4 pi epsilon naught Q into Q square by root 2L whole square. That's F1. Now plus root 2 into F. Now what is F? F is force between these two charges. That is 1 by 4 pi epsilon naught Q square by L square. Is it okay? Fine. That's it for now.